myself Pushpendra Kumar, and in last lectures we have discussed about how we can convert an NFA into its equivalent DFA. Today we are going to discuss another topic, that is the minimization of DFA. Minimization of DFA means how we can minimize the number of states in a DFA. Basically, whenever we have to design or we have any questions designing of a DFA, so any person can design with any number of states. Suppose person A design with 5 number of states and person B design with the 4 number of states of a DFA. So when we think about which one will be better, then the number of states, the DFA that have the minimum number of states will be the better. So today's my topic is how we can minimize the DFA, because designing of a DFA it's already a challenging task, and you can design with any number of states. We will start to design any DFA, so we can have any number of states, but at finally we can minimize the states. Now the point is, what is the meaning of minimization of states? Basically, we have a DFA with 5 states, Q1, Q2, Q3, Q4, Q5. The minimization of states means we can combine, if we can combine any 2 states or more than 2 states, then the total number of states should be minimum. In this case, if we combine these 2 states Q1 and Q2 into a single state, then the total number of states will be considered as 1, 2, 3 and 4. Now the DFA that have number of states 5, now it will be converted into a minimum number of states DFA that have 4 states. So today's agenda is how we can minimize the DFA. Now the first point is, on what basis we can combine the states, whether Q1 and Q2 is combined or Q1, Q3 or Q4, whatever, means how we can combine a states. What is the logic, what is the rules behind that? Let's say we can combine the states that are equivalent to each other. Means the states which are equivalent can be combined in the process of minimization of DFA. Now how we can find out whether these 2 states are combined or not? So the states which are equivalent to each other will be combined. So how we can find out whether the states are equivalent or not? So we have let's say we have 2 states, let's say Q1 and Q2. Then the states Q1 and Q2 will be equivalent only if delta Q1 X we get a final states, and similarly Q2 on the same input strings we also getting a final states. Either these conditions exist or delta Q1 on same input strings we are not getting a final states, or delta Q2 on same strings we are not getting the final state. Whether these 2 conditions exist or these 2 conditions exist, then we can say that the states Q1 and Q2 are equivalent to each other. And the main important thing is here, this is the input string, the same input string X. So states Q1 and Q2 are equivalent to each other if on applying the same input strings, either we are getting the final state or we are reaching to the final states, or we are not reaching to the final state. Then we can say that the states Q1 and Q2 are equivalent, and we can combine these states into a single states. Now the next thing is the types of equivalence. Basically, the length of the input strings is equal to 0. Then this is called 0 equivalence, and it is denoted by pi 0. If the length of the input string X is equal to 1, then it is called 1 equivalent, and it is denoted by pi 1. If the length is 2, then it is called 2 equivalent, it is denoted by pi 2. Similarly, if the length is n, then it is called n equivalent, and it is denoted by pi n. So these are the types of equivalence. Let's say we have this example and it is a DFA and we have to minimize the number of states in this DFA. Basically it has 5 number of states Q0, Q1, Q2, Q3, Q4, in which Q0 is the initial states and Q4 is the final states, and we have to minimize the number of states in this DFA. So how we can minimize the number of states in this DFA? First of all, we have to calculate the zero equivalence. Zero equivalence means we have to calculate the pi 0. How we will calculate the pi 0? The pi 0 is the set in which there are 2 types of states. One is the final states, and in one set is in the all non-final states. Means in this the final state set, how many number of final states are here? Only the Q4. So one element will be Q4 of this set, and another is all non-final, means Q0, Q1, Q2, Q3. Now we have to check which states are equivalent to each other, and the states which are equivalent to each other, we will combine that, and in this process we will minimize our DFA. Now if the states, if any set in this set, if any element has only the single element, any set has only the single element, then it will not be further break into any other subsets. So it will be not be checked. There is no need to check for the single elements. Now this is the set in which there are more than one elements. So we will check Q0 with Q1, with Q2, Q3. How we will check? Now we have to find out whether Q0 is one equivalent to Q1 or not. Now for this we have to prepare the transition table for this DFA. So what is the transition table for this DFA? We will convert it here. State input is 0 and 1, initial state is Q0, and states are Q1, Q2, Q3, Q4, and Q4 is final states. And whatever the output here, Q0, on applying Q0 we have Q1 transition, and on 1 Q2, on Q1 we have Q1, on 1 input we have Q3, Q2, on applying 0 we have Q1, Q2, Q3 we have on 0 we are Q1, and Q4, on Q4 on applying 0 we have Q1, and on applying 1 we have Q2. This is the transition table. Now we have to check whether Q0 and Q1 are one equivalent to each other or not. Now what is the process of checking this? On Q0 we will check what is the output on applying 0 input. On Q0, on 0 input we have the output Q1, and on Q1 we have output Q1, and both these states belong to the same set in pi 0. Q0 and Q1 similar set. Now we have to check for the another input. On Q0 we have on input 1 Q2 as an output, and on Q1 Q3. So Q2 and Q3 also belongs to the pi 0. It means Q0 and Q1 are one equivalent to each other. So we are calculating here pi 1, Q4 is addigit because it has only single elements. Now Q0 and Q1 are one equivalent. Now we have to check whether Q0 and Q2 are one equivalent or not. On Q0, when we are applying the 0 input, we are getting Q1, and on Q2 we are getting Q1. It belongs to the same Q1 state, Q1 set. On 1 Q2, and here Q2. This is also on same set, belongs to the same set. So this is also the one equivalent to Q0. Now whether there is a need to check for Q1, Q2, there is no need. If Q0 and Q1 are one equivalent and Q0, Q2 are one equivalent, then Q1, Q2 will also be one equivalent. Okay, now we will check for Q0 and Q3. On Q0 we are getting on 0 input Q1, and Q3 we are getting Q1. Q1 and Q1 belongs to the same set. Now checking for the second input, on Q0 we are getting Q2, and Q3 we are getting Q4. Q2 belongs to this set and Q4 belongs to this set. So Q0 and Q3 are not one equivalent. So Q3 remains different. So this is the pi 1. Now we will calculate pi 2 means 2 equivalent. How we will check? The single element, so there is no need to check for this. Now Q0 and Q1 are 2 equivalent to each other or not. So on Q0, on 0 input we are getting Q1 and Q1 we are getting Q1 and Q1 belongs to the same set in pi 1. When we are calculating pi 2, we will check in pi 1. So both belongs to the same set, so it may be 2 equivalent, but we will check for the second input. On Q0 when we applying one input, we are getting Q2, Q2 belongs this, and on Q1 Q3 belongs this, Q2 belongs this set and Q3 belongs this set, different sets. That's meaning Q0 and Q1 are not 2 equivalent. Now we will check for the Q0 and Q2. Q0 and Q2, Q0 we are getting Q1, Q2 we are getting Q1, Q1 belongs to the same set, and on one input Q2 and on one input Q2, Q2 belongs to the same set. It means Q0 and Q2 belongs to the same set. That's why Q1 and Q2, these are also not 2 equivalent to each other. Let's we check Q1 here and Q1 here, same set, Q1, Q3 here, Q2 here, Q3 at Q3 here. So this is Q1 again. So these are the pi 2 equivalents. Now we will check pi 3 and when we will stop, whenever we get the same 2 pi sets, then we will stop. So we are going to calculate pi 3 here, Q4, no need to check. Now check Q0 and Q2, whether they are 3 equivalent or not. On Q0, we are getting on 0 input Q1 and Q2 we are getting Q1. Q1 belongs to the same set in pi 2. On 1 Q2 and on Q2 belongs to the same set. It means Q0 and Q2 are 3 equivalent to each other. This is single elements and this is single elements. Since pi 2 is equivalent to pi 3, so we will stop the process of minimization. And finally, we are getting these sets. In these sets, Q0 and Q2 are 3 equivalent to each other. And these are the states which are equivalent to each other, and we can combine these two states. So finally, after minimization of DFA, what DFA we got? We have Q0 and Q2, the states which can be combined, means Q0 and Q2. And since Q0 is the initial state in the given DFA and here Q0 is, so this will become also the initial states. Next state is Q1, Q2, Q2 is combined, Q3 and Q4. And Q4 is the final states in the given DFA, that's why it will also become the final states. And now what will be the transition on Q0 applying? We are getting Q1 on 0 input, on 1 input we are getting Q2 and Q2 is combined, so that's why on 1 we are getting the Q2. On applying Q1 on 0 input we are getting Q0, Q1 also, and on 1 we are getting Q3. On Q3 applying 0 we are getting Q1, on Q3 applying 1 we are getting Q1, on Q4 when we applying 0 we are getting Q1 and applying 1 we are getting Q2. Q2 means this. So this is the minimum state DFA of this given DFA, and in this way we have minimized the states. That's all. Thank you.